Hello friends, I am Arpit and I am here with today's analysis. Today is 9th of April and we are going to discuss three very important topics which are in news. The first is semiconductor chips. Semiconductor chips are known to be the product of the millennium because these semiconductor chips are being used in day-to-day devices like any electronic equipment you will find this. You see it in the LED lights which are increasingly being used nowadays. You see it in the automobiles. You see it almost everywhere. Since digitalization is increasing, so the usage of semiconductor chips is increasing. Sadly, in India, the semiconductor chip manufacturing expertise is not there, which we are building right now. Tata has signed a collaboration with a Taiwan-based chip manufacturer. Now they're setting up a plant in Gujarat, which will start manufacturing by 2025-26. But there are multiple challenges like adequate infrastructure is not there, the cost is very high, or skilled labor is not available in India, and that has to be addressed. So we need to address this if we want to become, this, I would say a hub of semiconductor chip manufacturing. Next is Zaporizhzhia nuclear power plant. This is the biggest nuclear power plant in Europe, located in Ukraine, under control of Russia since the last 2 years, and is witnessing bombing right now. There were drone attacks on this nuclear facility. Did these attacks lead to leakages of nuclear radiations? Thankfully, not. But the risk is there. That needs to be addressed urgently. Actually, the nuclear power plants are made in such a way that they can withstand earthquakes of magnitude 7 to 8. These small bombings have not, disturbed it, but yes, we don't know about the big bombings or the big missiles coming and impacting these nuclear power plant sites. Adequate measures need to be taken in this case. And next is the buzzwords in global trade. There are four key buzzwords in global trade which are, very much in trend right now. First is offshoring, where a country, uh, offloads its operations, whether manufacturing or services, to another country. Second is onshoring or reshoring, where the operations are brought back to the country. That is the opposite of offshoring. Third is nearshoring, when in the nearby countries, preferably with which you share a border, you outsource those functions over there. Like in this case, the example is Mexico and USA. So USA has outsourced a lot of functions in Mexico. And the fourth is friendshoring. You outsource the functions in those states with which you share certain values. Those are your friends. And these buzzwords are doing the rounds in economics nowadays, and hence they are important for us to know. Now, with the first topic, let's get started, that is the semiconductor chips. Now, as I said, that semiconductor chips have become very, very important nowadays. We are living in a digital era, and this digitalization is going to increase in the times to come. It is not going to reduce. And so is the usage of semiconductor chips, which run those digital devices. Multiple functions can be performed by a semiconductor chip in any device. At times, this device or this semiconductor chip acts like a brain of that device. Like, for example, we all use ACs in the summers. You set a temperature on the AC, let's suppose that's set 24 degrees Celsius. Now, the semiconductor chip will be able to judge when the ambient temperature of the room has reached 24 degrees Celsius. Automatically, it will turn off the AC. As when the temperature increases, automatically it will switch on the AC. Now, this is some intelligent, I would say, thinking given to that machine through this semiconductor chip. The normal functioning of that machine also depends on the semiconductor chip, because this semiconductor chip is the chip which is responsible for receiving signals from the remote in that AC. So multiple functions can be performed by that chip. Now, since we are living in a digital age, usage of this semiconductor chip is going to increase day by day. Digitalization is being infused in our day-to-day lives. For example, earlier we used to pay toll taxes via cash and get that slip. Nowadays, you have FASTag. In FASTag, which is stuck in your vehicle, semiconductor chip is not there, but the device which is receiving the signal, that RFID tag which is installed on the toll plazas, that is having a semiconductor chip. So I gave this example because just to let you know that digitalization is getting infused in our day-to-day lives, in almost everything which we do and experience in our lives. And since this importance of semiconductor chips is increasing, we need to, revamp our manufacturing capabilities as well. And that is why the Tata Group has partnered with Taiwan's Power Chip Semiconductor Manufacturing Corporation, PSMC, to set up a 300 wafer fabrication plant in Gujarat. It will roll out its first 28 nanometer chip in 2026. Now, what does these two terminologies mean? 300 wafer to 28 nanometer chip. This will also be clarified because in this particular topic, we are going to study the art behind manufacturing of the semiconductor chips. Two assembly and testing plants are also coming up in Gujarat and Assam apart from this. So, India is wanting to become a very important node in the semiconductor supply chain all across the world. And digitalization, as I said, is increasing. It is not only increasing in India, it is increasing all across the world. So, we need to, do that. Now, what is a semiconductor chip? First of all, as the name suggests, semiconductor. So there are two types of devices when it comes to conductivity. One is called as conductor, which is conducting electricity. Next is insulator, which is not conducting electricity, and semiconductor is somewhere in between. Now, if I talk about the purest form of semiconductor on which no engineering has been done, that purest form of semiconductor is towards insulator, means it is a very bad conductor of electricity. So it is like this. In its purest form, a semiconductor is a very weak conductor of electricity. Now we do certain processes on that semiconductor to alter its electrical properties. Now the question here is, can electrical properties of a semiconductor be changed? So as I said, yes, we can do certain engineering processes or we can do certain processes on that semiconductor chip to alter its electrical properties. Electrical properties can be changed by adding small amounts of certain substances, and these small amount of certain substances are called as dopants. By taking a pure semiconductor and carefully injecting certain parts with specific dopants. Now it is basically equivalent to a painting on a wall or on a floor. You do a painting, you put a stencil over there on a wall and you paint it. Likewise, on a semiconductor chip should be analogous to that wall. On that semiconductor chip, you place a stencil and do that painting. That paint is called as a dopant or can be referred to as a dopant, and that stencil can be referred to as a mask. Why it is done? It is done to alter its electrical properties, because if we need in that particular semiconductor chip electrical properties to be enhanced, then we will add dopants. So it is like this. Now what is a transistor? Now apart from adding a dopant, transistors are also planted on that semiconductor chip. And this transistor is one of the most important components which is planted on a semiconductor chip because it has versatile functions. So it is a versatile device. What it can do? It can do multiple functions. Like for example, it can function as an electronic switch. A typical semiconductor chip can have billions of these interconnected switches that work together to perform various logical and computational operations. Now to understand this point, let us go back to our example where I said that you switch on a AC, you set the temperature to 24. As when the temperature of the room reaches 24 degrees Celsius, automatically that AC switches off. Switches off means the outdoor goes off. Only the fan of that AC will be working. And when the temperature of that room will be rising, it will switch on automatically. Means the compressor will start working of that AC. Now, how does this happen? There are multiple transistors which are there on the semiconductor chip mounted, which is there in the AC. And this is basically, giving the signal to the AC that when to stop, when to start performing those logical functions. So this is what a transistor can do. Transistor can also function as an amplifier. It can amplify the signals which that particular device is receiving. Let's suppose if I talk about a phone, and in that phone, Wi-Fi is there. Your phone is capable of receiving Wi-Fi signals. When it receives Wi-Fi signals, you are there at a place, let's suppose, where the Wi-Fi signals are weak. Now the transistors in your phone can come to work over here and can amplify the weak signals and bring those signals to normal. That work also, and a transistor can do. So this is what basically transistor is. It is versatile. So this is there. Now what is fabrication? Now fabrication is the process of mounting all these elements on that semiconductor chips. These elements, apart from after the dopant is applied, transistors are added, resistors are added, capacitors are added. And these, I would say, elements which are added on the semiconductor chip have become miniaturized. Miniaturized means their size has been reduced. The size has been reduced to an extent of nanometer. And by reducing their size, we have basically increased their efficiency. Now, the level of miniaturization of the semiconductor has increased. Sticking with the stencil analogy, this is mainly due to the stencils being able to etch smaller and more intricate patterns. Like he said that by using a stencil, we are putting the dopants. That stencil basically was called as masks, which we refer to in that example, painting on a wall. So on the masks are also made in such a way that these small elements can be planted on a semiconductor chip. There have been equally impressive gains in the switching capability. Switching means switch the transistors. They are also miniaturized. Now the question is, up to what extent miniaturization has been achieved? It has been achieved up to the extent of nanometers. So we see here 45 nanometers, 28 nanometers, 16 nanometers. And nanometer is 10 raised to power minus 9 meters. This is basically their 1 billionth of a meter, it is called as. So this is that small. And coming back to the first slide where I said ki these two terms will be explained to you, 28 nanometer chip. So the components which will be mounted on that chip will be of this dimension, 28 nanometer. They have been miniaturized up to this extent. Now in this dimension of a transistor, this nanometers and all, though not always accurate, you can think of this number as representing the dimension of a single transistor. But at times there are other elements also which are mounted, and those are also, of that particular dimension, nanometer. Is fabrication done in 2D or 3D? Actually, as of now, it is done in 2D. But scientists are looking towards translating it into 3D to increase the efficiency of that particular semiconductor chip. Because in 2D space is limited. In 3D, space can be increased. So with the 3D printing and all, which is there into, vogue right now, which is there into practice right now, we can introduce 3D also in the times to come. But as of now, it is largely done in 2D. Now, what is a wafer? This term also we should know. Like a postage stamp. We might all have seen postage stamps. If you have not seen, because you are the Gen Z, so I'll just explain. Postage stamp is like this. Another is attached over here. Like this, the postage stamps are there. There are 3 postage stamps. But when they are printed on a single piece of paper. And then, they are punched in this way that if we want to take out one postage stamp, we can take out one postage stamp easily by tearing it. So, wafer is that large paper, that large semiconductor, I would say, base wafer on which mountings and all are done. And then that semiconductor wafer is cut into single semiconductor chips, and those single semiconductor chips are used in whatever devices, let's suppose they have to be used. Now an array typically of 300 to 400 millimeter is being used right now. So 300 millimeter is basically the diameter of that particular wafer. So, and on this wafer, multiple, I would say, semiconductor chips are mounted, which are similar actually, and you cut these semiconductor chips to form multiple semiconductor chips out of one wafer. This actually increases the efficiency in manufacturing. If we go for manufacturing one single semiconductor chip, then it is going to take a lot of time, and the demand, as I said, is increasing day by day. We will not be able to meet the demand. So that wafer is there on which, that stencil is kept, the dopants are there, then the transistors are mounted likewise. So now coming back to the first slide where I told that I will be telling you about this. So the Tata Group and Taiwan's Power Chip Semiconductor Manufacturing Corporation is to set up 300 mm wafer fabrication. Means the wafer they will be using, Tata and this Taiwanese company, it will be having a diameter of 300 mm, and on that multiple semiconductor chips will be manufactured, and they will be cut into single chips and things will happen. The status of semiconductor chip manufacturing in India. See, the status of semiconductor chip manufacturing is not up to the demands of India. Since India is seeking to be Atmanirbhar in this domain, we already experienced a lot of, I would say, challenges during the post-COVID period when China used to say, "Ki bhai, we don't have semiconductor chips manufacturing, or if we have manufacturing, we cannot export it to you because of supply chain constraints due to COVID, and we were dependent upon them. So our automobile sector suffered a lot. So we decided at that time only that we want to become Atmanirbhar. We have the designing capabilities. We can design semiconductor chips. We have engineers. But when it comes to the manufacturing capabilities, there we are lacking. And that is why we are collaborating with multiple other countries to establish such kind of, I would say, industries in the country, which will not only cater to the domestic market, but will also, contribute in increasing the exports of this semiconductor chip, because the demand of this chip is increasing worldwide, not only in India. So this is the current scenario. We can, create computer aided designs of semiconductor chips. We have the engineers, but manufacturing expertise we are lacking. Manufacturing expertise. Why we are lacking? Because first of all, there is high cost of setting up a plant. It is believed that approximately $1 billion has to be invested. And apart from it, high-end technology has to be there in that, which we are lacking in. And countries like Japan or countries like Taiwan have excelled in this. And that is why with both of these countries we are talking. Countries like America also has excelled in this. We are talking with America as well. Then dependency on other countries for raw materials for semiconductor manufacturing. Fabs are being taken from other countries. The raw material, which is basically made from the rare earth minerals or rare earth materials. India has resources of or reserves of rare earth minerals, but yes, China has the largest. China has monopoly in that. So we will be able, we are dependent upon it on other countries. Then supply chain disruptions. They are also caused in our country. Poor infrastructure and logistics. Logistics is expensive. It is somewhere around 13 to 14%. The national logistics policy, which was rolled out in 2022, aims to bring it to single digit. That is somewhere around 8-9%. But yes, it will take time to come down. Infrastructure is not adequate, means electricity supply or road connectivity, rail connectivity, like this. They are, getting developed as of now. So presently, this is there. And lack of skilled manpower. This is also something which is missing in the country. So these are the challenges which we need to address if we want to become a hub of, means a global hub of semiconductor chip manufacturing in the world. If we are able to do so, then India definitely will be, a very important node in the global supply chain of semiconductor chips. Next is Zaporizhzhia nuclear power plant. Now this nuclear power plant is in Ukraine. You can see over here on this Zaporizhzhia nuclear power plant, a drone strike. Zaporizhzhia nuclear power plant happens to be Europe's largest nuclear power plant, world's 10th largest nuclear power plant, is under control of Russia since the last 2 years when the war started. Ukrainians are working. Electricity is produced in this, and this electricity is supplied to Ukraine. Now, who attacked Zaporizhzhia nuclear power plant? Since it is under control of Russia. So Russians are saying that Ukraine has launched that attack. International Atomic Energy Agency, IAEA, which is basically the global watchdog for nuclear, I would say, power generation and all, and nuclear fuels and nuclear bombs also. So this agency has said that at least there were 3 direct hits, but it did not say who was responsible for these hits. That is something which is there. Then was nuclear safety compromised? Now, by this attack, thankfully, nuclear safety was not compromised. But yes, this does not mean that this facility can withstand more attacks, or more and more attacks can be there, or recklessly we can attack this facility. There is increased risk of nuclear leakages due to these attacks. Okay, by this attack, there was no nuclear leakages, but yes, there can. A brief about Zaporizhzhia nuclear power plant. It is basically one of the 5 nuclear power plants in Ukraine. So apart from this, there are 4 other nuclear power plants in Ukraine. It is Europe's largest nuclear power plant. Capacity is 5700 megawatt, and half of electricity demand of Ukraine comes from this. Half of electricity demand through nuclear energy comes from this. Means this particular nuclear power plant is generating half of the total, I would say, electricity generated from nuclear power plants in Ukraine. Now, the drone attack came 3 days after the power station suffered its most recent loss of external power supply. Now, we need to understand this thing that nuclear power plants do have external power supplies also. And every nuclear power plant in the world has this. Why? Because, in case of emergency, these nuclear power plants, if there is outage of electricity, with this external power supply, electricity can be provided, water can be pumped in the reactor to cool down the reactor. If this external power supply goes off and the power, in the nuclear power station also goes down, then, in that nuclear reactor, the reaction will become uncontrolled nuclear reaction, which will definitely lead to leakages. This is more, I would say, dangerous. This Zaporizhzhia nuclear power plant has 8 sources of external power supply and all the 8 sources were cut. That has a more higher risk of leakages. The power station has also faced frequent shelling and mortar attacks from both sides, which has made this particular site as the most dangerous nuclear site in the world currently. And shelling and bombing has been happening since 2022. But this is the first time where the shelling and bombing has happened in the premises of that nuclear power plant. Now, how resilient are nuclear power plants? Most nuclear reactors are made of several layers of steel and concrete and are designed to absorb shocks from earthquakes of magnitude 8 or even higher. Now, can shelling impact the power plants? Ordinary shelling or gunfire can't impact. That is something good news, and that is why this drone attacks did not impact. But we don't have any data about a big missile or a big bomb coming and impacting this particular facility. What impact it will have? Obviously, there is risk of leakages. So we need to understand this in this way. And the last piece of news, that is buzzwords in global trade. Basically, there are 4 buzzwords in the global trade right now. First is offshoring. Second is reshoring or onshoring. Third is nearshoring. And fourth is friendshoring. Now let us decode each and every word and let us see how this is. Now this is when a company moves business operations to another country. Offshoring. Quite commonsensical. Reasons for offshoring: this new country might have cheaper labor. Right kind of personnel are more available in that country. Many a times the developed countries offshore their operations to conserve their natural resources. Now here I'll take an example of Apple. Apple has offshored its manufacturing. The phones, laptops, iPads and all are not manufactured in USA. They are manufactured either in China or in India. Reason might be cheaper labor over here. Right kind of personnel are available over here. Maybe USA wants to conserve its natural resources for its future generation and are not exploiting it right now and have outsourced this to other countries like China and India, which are developing countries. Now we know that, our resources will be exploited, but we also have to generate employment in our country. That is why we accept these kind of offers. We have to focus on the secondary sector, which has the highest, employment generation capacity. So this needs to be taken care of. Is manufacturing only offshore? See, only manufacturing is not offshore. At times, the accounts department is offshore. At times, you will see, the customer support department is offshore. Like in India, a lot of, I would say, call centers were there. They are still there. They are basically catering to the businesses of the Western countries. So it is like this. What is reshoring? Basically, this is the opposite of offshoring. Not opposite of reshoring. It is the opposite of offshoring. It is also known as inshoring or onshoring. This is when a business transfers its processes back to its country. Now, in that example, again, Apple, let's suppose it starts manufacturing in its own country. Why will Apple do that? Maybe in India or China, there will be more fragility of the global supply chains. Means they are able to manufacture, but they are not able to supply this. So in that case, reshoring will be done. So this is there. What is nearshoring? It is when a company locates a process in a nearby country where labor is cheaper and channels of shipping and communications are strong. The two countries often share a border with each other. In this case, a classic example is USA and Mexico, which, USA has outsourced a lot of, I would say, its business operations in Mexico, and Mexico has now become the biggest exporter to USA and it has surpassed China. Last is friendshoring. You have a friend, means a country with which your relations are good, you share common values as well. So you transfer your businesses over there. Like again, if I take that example of Apple was first being manufactured in China. Now, for Apple, a manufacturing unit has been set up in Chennai, in Tamil Nadu. So, USA was, I would say, the problems between USA and China had been increasing, and thereby USA responded by relocating Apple over from there to here. So these terms have to be known, and that way there are likely to be fewer supply chain disruptions. This is basically what we need to understand. Now comes the MCQs, the 5 MCQs which we see. Now, first is consider the following statements and mark the correct one. First is semiconductor has properties between that of a conductor and insulator. Second is in its purest form, semiconductor is a weak conductor of electricity. You have to, mark from these which is right. It is very simple. Second is a direct question. Function of a dopant. What is a function of a dopant? Out of these four, you have to choose the correct one. It can function as an electronic switch. It can alter electrical properties. It can function as an amplifier. None of the above. Next is consider the following statements and mark the correct one. Zaporizhzhia nuclear power plant is the largest nuclear power plant in Europe. Second is Zaporizhzhia nuclear power plant is under Russia's control. You have to answer. Next is purposefully I have not dealt with this, but yes, it depends on your observation skills how you answer this question. But Zaporizhzhia nuclear power plant is located on the banks of which river? So here are the names of the river, and you have to answer among them. And last, assertion reasoning. Assertion statement is offshoring is when a company moves business operations to another country. Reasoning is offshoring is done keeping in mind the availability of cheap labor in the country where operations are outsourced. So A and R are correct, and R is the correct explanation of A. So you mark A. If both A and R are correct but R is not the correct explanation of A, you mark B. A is true, R is false. A is false, R is true. So accordingly, you mark terms and get the answers. So with this, I come to an end of today's session. I will be meeting you tomorrow now with more such informative news pieces. Till then, you guys very well know what to do. Keep studying, keep reading, keep writing, and most importantly, keep revising. Namaste. Jai Hind.